Hello everybody. Once again I am here with you for the another part of this Debye model and of the lattice heat and capacity. In the previous session we have seen the number of modes of vibrations for the three dimension, or basically we can say uh, three-dimensional harmonic motion is to be there. And here what exactly the Debye's assumption regarding the frequency limit, that is somehow it is called to be as an Debye approximation, and it is somehow given in this small video. And basically when looking for, it is also the part of the your Debye theory of the lattice heat capacity, but basically sometimes the Debye's approximation may be the question for the 5 marks, and that's why I'm taking it as a separate video for this Debye approximation. No doubt it is the part of our Debye theory of the lattice heat capacity. Now basically when this number of modes of vibrations we have taken into account, the whatever be the interatomic distances as far as the crystal is going to be concerned, if the interatomic distance uh, is small as compared to the wavelength of the elastic wave is to be there, that means the interatomic distances as far as the your atoms are going to be taken into account, that two atoms are in taken into account, that is we can say here it is to be as an we already seen that the solids are to be connected to each other, and the whatever be the interatomic distances is small as compared to the incident wavelength of the whatever be the elastic waves are to be there, the crystal can be regarded as a continuum model or regarded as a continuum from the whatever the point it is to be applicable seen. And basically with these assumptions, basically the based on this idea, the Debye assumed that it is to be as a continuum model is applicable for the possible modes of vibrations are to be there, and that's why he has taken as a continuum model for these modes of vibrations are to be there. And again the crystal consists of basically the finite number of atoms, whatever be the diagonal axes, three dimensions are to be taken into account. Either we are taking in the one dimension, there are number of atoms are going to be limited, and that is nothing but to be the finite number is to be there, and that's why it is given n is to be as an finite number of the atoms are present in the particularly having the whatever be the crystal or the solid is to be there, and that gives fixing some amount is to be the for the limiting the particular total number of vibrations, vibrational modes to 3n are to be there, and this is somehow the limiting modes of vibrations are nothing but to be 3n is taken or assumed by the Debye. And somehow it gives you the upper limit for the frequency basically for the elastic wave, as the elastic wave is going to be generated because all the atoms are going to be connected to each other, bonded with each other, whatever be the vibrations that will produce to be as an wave, and that is to be as an your elastic wave is to be there. And in this case the whatever be the limit taken by the Debye or assumed by the Debye, it gives some sort of limitation for the modes of vibrations basically, and the it is somehow 3n be the number of vibrational modes limiting the account for the number of atoms, it gives the limits for the upper hand, and that is somehow limiting the upper frequency range, and that is the highest frequency propagating through the crystal is nothing but to be called your Debye frequency, or nu d is to be there, it is noted by nu d, म्हणजे जी काय maximum frequency ni modes of vibration होणार आहे, it is somehow limited to the Debye frequency, and it is denoted by the nu d is to be there. And it is again the whatever be the frequency as far as the types of the waves are too, that is transverse wave, that is propagation of the particles, whatever be the vibrations of the particles are perpendicular to the direction of the propagation of the wave is to be there. And in that case also, or longitudinal, where the vibration of the particle is along the propagation of the wave is to be there. And in this case whatever be the upper limit for the vibrational mode, that is the Debye frequency, is going to be the commonly taken, and that's why the transverse as well as the longitudinal modes of vibrations are going to be common, and hence the frequency spectrum from the of the continuum medium is cut off of the Debye frequency. It is shown in the next slide, and that is somehow given with the total modes of vibrations, and basically with this total number of vibration modes with the frequency ranging from the nu to nu d is to be given, and basically with this part 0 to mu d, that from 0 to particularly upper limit is not going to be as an infinite, it is up to the Debye frequency it is going to be limiting, and whatever the modes of vibrations we have calculated yesterday, that is given with the z mu relation, we can now write that relationship or putting the integration for this particular limit by the Debye, and that is nothing but to be Debye frequency limit. Then it will give us the relationship to be as like this, that is integration 0 to mu d nu d, very much important factor. It is 0 to nu d is to be there, this factor. Z nu d nu is equal to 3n, total is to be as a 3n number of modes of vibrations are to be there, and that's why the relationship is nothing but to be like this. I can write integration 0 to nu z nu d nu is equal to 3n is to be there. Now putting these values of this relationship to be as an in the previous 4.80 relationship is to be z nu d nu is equal to 4 pi v into 2 by vt cube plus 1 by vl cube is to be there, and mu nu square d nu is to be the relationship was to be there. Now putting these values for the z nu d nu is to be there, and in this case what is this? This is total number of modes of vibrations for the 3-dimension harmonic motion is to be there, and now integrating this for the Debye limit or the Debye frequency limit we can say, and it is nothing but to be from 0 to nu d is to be there and is equal to 3n. Now rearranging this, what I can do or what we can get with this integration, no doubt 0 to nu d it will affect to only this nu square d nu, all r remains to be as a constant, this part will be remaining to be as a constant one, and that's why the whatever be the constant value it is to be remain as it is. That's why it is 4 pi v into 2 by v suffix t cube plus 1 by vl cube is to be there into what is the integration for this nu square d nu, definitely it will become nu d cube by 3 is to be there, एक नि वाढेल आणि divided by 3 जेवढं वाढलं ते is equal to 3n is to be there. So this is what the new relation we found, but I need to find the nu d, that is the Debye frequency limit, how much it is to be, then I can write for this relationship. मग जर ह्याला मला न्यू डी क्यूब जर लिहायचं असेल तर रिअरेंज करावं लागेल या इक्वेशनला, तर बेसिकली जर सुद्धा सुरुवातीला न्यू डी क्यूब बाय 3 ॲज इट इज ठेवलं तर हे जाईल राईट हँड साईडला, मग हे जर राईट हँड साईडला जाईल तर बेसिकली काय होणार आहे 3n डिवायडेड बाय लिहावं लागणार आहे, 3n डिवायडेड बाय मला काय लिहावं लागेल 4 पाय व्ही असं, 3n डिवायडेड बाय 4 पाय व्ही, इथं बघा ॲज इट इज बेसिकली हा जर समजा मी इथं लिहिला तर म्हणून इथं काय झालं n बाय 4 पाय व्ही असं आलेलं. आता 9 कसं आलं ते पण सांगतो. हा बेसिकली 3 इकडं जर गेला 3 इकडं जर गेला 3 × 3 9 म्हणून 9n सॉल्वड, आणि आता न्यू डी क्यूब म्हणून इथं न्यू डी क्यूब. आता हे डिवाइड जाणार आहे पण उरलेला पार्ट हा सुद्धा ह्याला इंटू डिवायडेड बाय आहे 2 बाय तुमचं जे काय व्ही टी क्यूब प्लस 1/VL क्यूब इज टू बी देअर. पण ह्याला जर मला रिअरेंज करून लिहायचं असेल तर हा वर येऊन त्याला मायनस पॉवर दिलं म्हणजेच त्याचा अर्थ काय की ते डिवायडेड बाय आहे. मग यावरून काय लिहू शकतो मी, आय कॅन राईट द वॉट एव्हर बी दी Debye फ्रिक्वेन्सी or the Debye approximation is nothing but to be basically given with this relation to be as an nu d cube is equal to 9n divided by 4 pi capital V into 2 by Vt cube plus 1 by VL cube is to be there, VL cube टू द पावर -1. -1 पावर असणं म्हणजे काय, ते डिव्हाइड आहे, दॅट इज टू बी देअर. दिस इज वॉट द सम हाऊ द रिलेशनशिप इज टू बी 4.82 is to be there. Now putting this in consideration, whatever be the continuum spectrum if you will draw for the both the frequencies, that is to be as an the equation can be used to determine the nu d, no doubt. न्यू डी कॅल्क्युलेट करण्यासाठी आपल्याला ते इक्वेशनचा उपयोग होतो. आणि बेसिकली जर समजा स्पेक्ट्रम ड्रॉ केला, फ्रिक्वेन्सी स्पेक्ट्रम फॉर द ट्रान्सवर्स अँड द लॉन्जिट्युडनल वेव्ह, द कॉमन चॉप इज टू बी, इफ यू कॅन सी, ह्या बघा हा कॉमन चॉप इथं दाखवलेला आहे. दिस इज टू बी नथिंग बट टू बी युअर न्यू डी. Actually this is what the frequency along this axis, and here it is to be as an z nu is to be there. And cutoff showing Debye frequency is nothing but to be shown with this case. Now here modes of vibrations with this frequency range, whatever be the ratio is to be there, and it is cutoff range is to be shown here. Now what it indicating, it is to be equation definitely gives you the relationship for the calculating the Debye frequency. And taking velocity of the sound around 10⁻³ meter per second जर समजा घेतली, and n by v is equal to nothing but to 10⁻, मग त्याच्यावरून आपल्याला frequency n by v when we can going to calculating, it is nothing but to be 10⁻28 per meter cube is to be there. And according to this we can get the nu d is equal to 10⁻13 is per second. And this approximation gives you the approximately gives you the wavelength nearly 1 angstrom unit. And this is somehow, if the wavelength is 1 angstrom, it is showing you that is the distance in between the two nearly atoms is to be there, which is of the same order of interatomic distances. म्हणजे जेवढ्या वेवलेंथ जी काय यायली ती काय इज इक्वल टू कुणाच्या यायली, इज इक्वल टू यायली व्हॉट एव्हर बी दी इंटरॲटॉमिक डिस्टन्सेस, म्हणजे त्या ॲटमच्या डिस्टन्स एवढीच वेवलेंथ त्याच्यामध्ये यायली. अँड विच इज द ॲक्च्युली सम सॉर्ट ऑफ पुट सम क्वेश्चन मार्क ऑन दी व्हॉट एव्हर बी दी Debye's assumption वॉज टू बी देअर. आणि हेच पुढे जाऊन ह्या पर्टिक्युलरली ही लिमिट टाकल्यामुळे याचे लिमिटेशन्स म्हणजे पर्टिक्युलरली Debye मॉडेलचे समहाऊ व्हॉट एव्हर बी दी पुट ॲज अन क्वेश्चन मार्क फॉर द व्हॅलिडिटी ऑफ द कॉन्टिनम थिअरी, म्हणजे ही कॉन्टिनम थिअरी अलाउड आहे आणि त्याच्यावर थोडासा त्याचा क्वेश्चन मार्क तिथे तयार होतो. अँड बेसिकली particularly in the higher frequency region it is going to be the problematic. Furthermore the velocity your vt, that is transverse velocity, and vl, that is longitudinal, have been assumed to be as an independent of the wavelength, which may not be again true. And how this velocity is going to be independent of the wavelength, that is somehow putting question on this, what the Debye's approximation is to be there. But we made it a short video for because of this might be question for the 5 marks short note, that is the Debye approximation. Then you have to write up to this much what exactly limit has been taken and how it spectrum is going to be formed. And this is what the Debye's approximation. And in the next part we will see what exactly to be as an your basically related to the energy calculation for the Debye model using the Debye model. Till then, take care. Thank you.